Before we are ready to export G-code, which is the code that a 3D printer needs in order to know what and how should be printed, we need to adjust our print settings for our specific filament. We are going to start printing with the Recreos 95A, or depending on what type of filament you have at home or what type of filament you have been given in the package, you can start with the one that has the highest shore hardness. What is shore hardness? Well, shore hardness determines how flexible and how bendable is the filament. The lower is the number, the more flexible it is. It's also a little bit more challenging to print from the flexible materials that are very, very flexible. And I'll explain in a second why. So for us to start easy, start with the filaments that have higher shore hardness. So if you can start with the flexible filament of shore hardness 95 or 85, whichever is at your home or available to you, then start with the ones that are more rigid. Still flexible, but rigid. I'm going to start with the filament with the Filaflex 95A, which is quite rigid, it's still quite hard. You can create beautiful prints and beautiful 3D printed fashion with this type of filament, but the best filaments for 3D printed fashion combine also the durability, but it's easy to print from them, are the ones around 80. So 80A, 85A, 82A are the best filaments that I would recommend to print 3D printed fashion, but you can start with those that are a little bit more rigid. Let's go to our Prusa slicer and start changing the parameters for the filaments. I'm gonna head to the print settings. We already have the generic flex selected here. So I'm going to head to print settings. So the most important properties that we have to adjust and that affect the quality of the prints are the temperature of the bed, the temperature of the nozzle, speed, retraction speed, and travel speed. Don't worry, I'll go through each of the parameter itself and I'll explain which of the parameters affect what. So the first that we are going to start with is temperature. So if you can navigate towards either in Prusa Slicer or in your slicers to find space, to find temperature of nozzle and temperature of the bed. You can, if there is any search, then you can even search through it. Prusa Slicer offers searching. I do believe that most of the slicers have search bar available. So let's have a look for temperature, and I'm gonna click here on the bed temperature, and you can see this arrow pointing at the space that I wanted to adjust, and then I can adjust. Usually you have the opportunity to have different temperature values for the first layer and the other layers. We are going to start with the temperature of the bed. As I've told you from my experience, even though most of the vendors say that you don't have to preheat your bed, but from my experience, if you do preheat your bed, it usually makes the filament stick better on the surface and it produces better prints. So we're going to have our first layer set to 50 and our other layers keep set to 50. As we are there, we are going to adjust also the temperature of the nozzle. How do I know how to set the temperature? Well, the best way is to research the filament that we are using, because the vendors usually give us a range. It's very important to keep the temperature values within the range, because if you go below the temperature, you might get the filament stuck inside of your 3D printer. And if you go above the temperature, then you might start burning the filament. And burning doesn't mean that it will cause fire. Well, but it's not usually healthy to burn the filaments and inhale the fuels from the burned filament. So it's better to keep within the range so you keep safe, so you keep yourself safe and also your students safe. So please make sure that you are always within the range of the recommended temperatures from the vendors. Let's check for the Filaflex 85A that I'm going to print with today. So if I go open the print parameters and if I check for Filaflex 95A, then I can see that the printing temperatures are from 215 to 250. I'm going to choose something in the middle and I'm gonna say that it's 230. When we are starting with 3D printed fashion and printing with our flexible filaments, it might sometimes be difficult to find the perfect settings, But after this chapter, after this whole module, you should have your swatch book full of samples with research of the perfect temperature for your 3D printer, because it does differ from one 3D printer to another, from one environment in which the 3D printer is to another. There isn't any perfect parameter that will guarantee that you will have the perfect setting now in the moment. But what we can do is we can learn how to adjust our parameters so it fits, and how to react to the feedback that we get from the prints and from the printer to adjust our parameters. I will explain every single part of the research in the other module. Now let's go and look at the speed. The speed determines how fast will the printer be printing. So how fast will the filament be extruded. Let's have a look what the Recreos has suggested to us to be the best speed. So if I look at Filaflex 95A, then the print speed is between 20 to 70 millimeters per second. So I'm going to start with lower speed. It's always better to start with lower speed. But again, you don't want to print slowly just to print slowly. We want to hit the best settings for our printer. So when you'll be doing your research, try different speeds and then compare which of the samples work the best for you. So we're going to hit, if we have perimeters, which are the walls, and the walls, as you can see, can be printed a little bit slower. So I'm going to adjust it. I'm going to say 35, and with small parameters, I'm going to go with 20, external also 20. The infill is above the range that we are suggested, so we are not going to go with infill with 80, but we are going to change the infill speed to 60 as well. Top solid infill we don't have, support materials we also don't have. Bridges and gap fills, I think we can leave them. 25 is quite good, and gap fill also can be left as it is. We are also going to check what is the first layer speed. And the first layer speed that we have here is 20, and 20 is the actually slowest speed that was suggested by Recreos. So we're going to leave it as it is. If you don't have it there, then please adjust the first layer speed to be 20 millimeters per second. Perfect. Now that we have temperature and speed, we have to move to retraction speed and travel speed. Since I'm here on this card, I'm going to go travel speed first. So the travel speed is the speed that the printer has in between 2 points that are not connected. And when we are printing with flexible filaments, what we want to do is to make sure that the travel is quite quick. Because since the filament is flexible, it has the tendency to create these hairs. And just imagine something that is flexible. The longer that it takes to elongate the material, the more it's like hairy and it takes time. But if you jump very quickly, then the material breaks and it doesn't leave these hairs on the prints. So what you want to do is to adjust the travel speed and make the travel speed as fast as possible. So make it as fast as it's possible on your printer. I have travel speed here 180. My maximum print speed is 200. I can leave it 180 or I can move to 200. I'm not gonna adjust the Z level, which is the level and the travel speed of the movement of the hot end vertically, because it's usually better to leave it slow. Wonderful. So we have the travel speed. Now we are missing the last part, and that's retraction speed. So we're going to head to retraction speed. Let me explain firstly what retraction is. Retraction is a mechanism that allows the printer inside of the hot end to push the filament. Imagine that you're printing the filament through the nozzle down, and you create pressure for the filament to go down. Especially when we are using flexible filaments, the pressure is very high, and what it creates is that the flexible filaments keep printing even though it shouldn't. So we have the mechanism in the 3D printer that pushes the filament up and alleviates the pressure, so it avoids printing when it shouldn't. The problem with the retraction speed is that it pushes the filament back, but also the filament there is another force that pushes the filament to go down. What it sometimes creates is tangles inside of your hot end. So even though the retraction speed is would be wonderful if it worked perfectly. Usually we are advised to disable the retraction speed almost to 0 or have very slow retraction speed. I did print with flexible filament on Prusa printers, and I didn't have a problem with retraction speed. So I even made the retraction speed faster because, as I said, in ideal world, it helps you to stop the oozing and the hairiness of your 3D printed designs. So when I was printing on Prusa printers, it didn't do that. But when I was trying to print on other printers, I discovered that the retraction speed is really not helping the print. So depending on your printer, if you're using Prusa printer, then you can leave the retraction speed as it is, maybe even make it faster because you want the pull to be fast. So again, imagine that you have like a elastic, and if you just slowly push it, then it creates a lot of hairs. But if you pull, then it breaks and it cuts. So we don't want it to create ooziness and hairy designs. We want our designs to be as clean as possible. So if you're using a printer, it is a Prusa printer, you can leave the retraction speed as it is, maybe go even a little bit higher. And if you're not using a Prusa printer, then you will disable the retraction speed to 0. Again, you will have the opportunity to make your research for your printer. So anything that is here is not set in stone. It's just the guidance for you to start printing with a 3D printed textile. You will have plenty of time to explore as well what are the best settings for your printer specifically. If you decide to choose the retraction speed to some number, then don't forget to also adjust the retraction length. The retraction length is the length of how much should be the filament pulled. So you can make a small retraction or you can make a very big retraction. Usually the filament provider will tell you how far should be your retraction length for the best result. So if you are using, for example, Recreos 95A, and you decide to have retraction speed in there, then the retraction should be about, let's say 3.5, but let's put 3.0 millimeters for the retraction length. Sometimes the retraction length in other slicers will be named retraction distance. So retraction length and retraction distance is the same property. Now that we have the retraction speed down, we have to adjust a little bit more on the side of the filament, the specific parameters that affect the filament. We are going to check the diameter. We have to check that the diameter is set correctly, which is 1.75 millimeter. And then we have 3 more parameters that we have to check. The first one is density, which tells us specifically the composition of the filament. So different filaments, even though there will be TPUs of same shore hardness, can have different density because of the composition of the materials inside of them. So letting our printer know what type of filament and what density of the filament is there can help the printer make more accurate prints. And then there is filament cost, which can help us calculate a price for filament. It's not something that can help us with our prints, but when we are, for example, planning for our projects, we would definitely like to know how much would that cost, how much would our project cost. If we set the cost for filament inside of our slicers, then we can have there the information, and the slicers will, each time we slice a piece of fabric, give us also the cost of the fabric. So let's have a look at these properties. We are going to search for density. We are going to find the product, which is Filaflex 95A. Perfect. So let's search for the density of the 95A Recreos Filaflex. So I get the answer that the density of Recreos Filaflex 95A is approximately 1.2. So I'm gonna head back, and here the density is set to 1.22. I'm gonna just adjust it and write 1.20, and we are going to calculate the price. It says 33.76 euros per half of kilo, so we have to do double of the amount, which is approximately 68 euros. So let's make this 68 euros. And the spool weight is 500 grams. When we have the density, cost, and the spool weight, we can move to one last property to adjust, and that's the flow rate. When we are printing with the TPUs, it's important to adjust the flow rate, either before we do it in our Prusa slicers or in our slicers in general, or we can do it on our printers. The flow rate is the amount of filament that has been pushed through the nozzle, extruded in, and we can say that we want a little bit more. And when we are printing with TPUs, we want to push a little bit more, because since we are using flexible filaments and we are working with the flexibility of the material, we want to help the 3D printer to push out the filament correctly, so it doesn't, because imagine the filament, as I've told you before, like elongates when we stretch it, so it makes the material thinner. But we don't want to make our prints thinner. We want them to be thick as they were normal. So we are trying to adjust the flow rate, the amount of the material that's being pushed out, to compensate for the flexibility of the material. So we're going to say that the flow rate is going to be a little bit bigger, and that's 1.1. The bridge flow rate, and here we are going to say that we want the default extrusion width to be a little bit bigger. And usually we want the extrusion width, which is the flow rate in other words, to be 1.1. So if the flow rate, if 100% is 0.45, then the flow rate should be added by 5. Instead of 0.45, I'm going to say that I want it to be 0.5, and I'm going to change it for all of the parameters, infills, so it also fits. Top solid infill, like we don't have a solid infill, top solid infill is not there. And then the first layer, we're also going to change the first layer to print a nice thick layer, because still when we are printing with rigid filaments, we don't want that. We don't need the excessive amount of filament, because the filament that is rigid, that is firm, doesn't stretch, so we don't have to do it. But since we are working with TPUs that are flexible, and the pushing out of the filament is making the material a little bit thinner, then we have to compensate with pushing out a little bit more of the filament. Wonderful. This is all of the settings. It looks exhausting, but I promise it's not so exhausting. It's just the first step that needs to be done. Once you're used to it, once you already have all your files saved and all of your settings saved, then you don't have to do it again and again. It's always the hardest to do it for the first time. So congratulations that you made it here. Now we can finally head to exporting our swatch. So I'm gonna go back to the main site, to home, to the plater, and I'm gonna click on slice now, because we have adjusted a lot of settings, so it will prompt us to slice the file again. As you can see, not much has changed, because we've changed mostly parameters that are going to affect the print, not the object that we are printing. And here at the bottom, you can see all of the information that I've told you about. So how much of the material will be used in grams, in meters, the cost of the material, which now it should be 0.05 euros, which is basically 5 cents. And it should take us 7 minutes to print this swatch. What I want you to do before you start exporting the G-code, please take out your swatch books. And in your swatch books, write down all of the information about your project. This is why we have the swatch book. The swatch book is the place where we look to when we want to look for settings that we used. And I cannot stress it enough. And in every course that we have, I always have someone coming to me in 3 months asking me about the settings that they use for a specific project and how it's not working now, and it used to work. So save your future self time and nerves, and please write down in your swatch books all of the settings. So write down the temperature, the speed, retraction speed, travel speed. The rest of it can be found on the internet. So temperature, speed, retraction speed, travel speed is the most important. And then write down how long did it take to print this piece, the estimation of the Prusa. And how much filament have you used?